Hello everybody. Today I'm going to present about wireless temperature monitoring for my emerging technology project. And a brief introduction on what this project is all about is basically it is used in environmental lab situation. It is not just limited to environmental lab, but any place like food technology or pharmaceuticals, and other kind of labs. And right now, even vaccines are using strictly um, monitored temperature controlled units. So for this project, I'm using the environmental lab setting where samples must be stored in a cooler between 0 to 6 degrees centigrade. And there's a lot of instruments also that are used in various tests that has to be certain temperature, like BODs have to be 20 plus minus 1 degree centigrade, and various suspended solids, dissolved solids, which is used in wastewater and surface water analysis. They are dried in the oven, 104 and 180, and that also has to be within a certain range. And also, one of the most important is microbiology tests in drinking water that has for fecal coliform it is 44.5, and for total coliform and HPC bacteria that's 35 plus minus zero point 0.5. And the thermometers used for these instrument and environments have to be certain specifications, like the resolution has to be zero point 0.1 and accuracy has to be within 1 degrees, and the thermometers have to be traceable, and the temperature has to be monitored twice daily, and it should not go out of range. If it goes out of range, then we will be in a lot of problems. It can result in test invalidation, or we have to qualify data and take necessary corrective actions. And all of this requirement comes from the guidelines from the NELAC Institute, TNI, and Department of Defense if you're doing any DoD work. So what are the current issues the lab is having? Um, so the lab is currently using, you know, anywhere from analog to digital thermometers also, um, where you have to manually keep a logbook and record the temperatures by hand. And there will be a high chance of errors in manual transcription of data. And if they go out of compliance, let's say overnight or something, then there's no way to send out a warning system um, or record that data somewhere. And there's also lack of continuous monitoring, and there's also a burden of logbook maintenance throughout the years. And the solution that this project is going to implement is we will have highly accurate temperature probes, and will have no need of manual recording. The data is transmitted wirelessly, and the data integrity is pretty solid, um, unless there are security issues, of course. Um, and then there will be continuous monitoring, and there will also be warning and alert system via email, and uh, there are various options for data storage and data intelligence technology. By the data intelligence technology, I mean like there will be various ways of interpreting the data that's collected by graphs and trends analysis. So what are we using here? It is an instrument made by the TND company, and it's a TND data logger system. TND temperature data logger system is a continuous temperature monitoring system that uses a wireless LAN connection to collect temperature readings in cooling and heating units in the lab. The system is comprised of the following components. It has a network base station. It has a remote unit that is data logger with an external probe. It also has a repeater. Repeater is not necessary unless you want to enhance your signals if there is a hindrance. And the software used is RTR 500W for Windows. And they also offer a free web storage service. So here's schematics of the whole the network of RTR system. So this unit here is the network base station, which can be either wired or wireless both, and they can receive signals from the data loggers, and then they're connected to your LAN, where this PC is going to um, basically dictate the whole environment where the devices are going to be registered and all the settings are going to be entered here. And from there, we're going to configure various things like SMTP for email and FTP and web storage. So these are various ways that you can set up an alert system and a data recording system. So let's talk about network base station. Now the RTR 500NW and 500AW. 500NW is the wired LAN and 500AW is the wireless LAN version. The RTR 500NW is a network base station with built-in wireless and LAN communication capabilities. It can be set up to automatically download recorded data from wireless data logger with probe via wireless communications. It can send the data via network to an email address FTP server or TND's web storage server. It can also monitor for warning and send warning reports across a network to specified addresses. So like I said before, RTR-NW is for wired LAN, RTR 500AW is for wireless LAN connection. It's a pretty sleek model. The communication protocols used are SMTP, FTP, SNTP, DHCP, and DNS. So I try to condense the setup as much as possible. So this only highlights main points. A lot of the things can be found in the sources section of this presentation, where I have given the links to the manuals. So the most important thing here is the first step is to install the RTR 500W for Windows software with a CD-ROM. And once you install it, it's a pretty basic installation step, and you can just open it and it goes directly to RTR 500W settings utility. And at that point, you can unpack and you can screw the antenna and do the basic setup and connect it via USB cable. You don't need to put the AC adapter quite yet. And then that installs the driver in the PC, and after the driver installation, the default factory settings will be displayed, which we need to change. We need to edit base unit settings like name of the device, description, units, LAN password will be default, so we need to change that to a complex one. Edit the clock settings, time zones, date and time format, and daylight saving time, etc. And then you have to click apply. And after that, we will be configuring network and email settings. We can update settings for wireless communication to transmit the recorded data, update email settings to send readings, recorded data, and warnings via email. And for that, you need to enter some network information like IP address, DHCP, DNS, and FTP servers, etc. that is available with your sysadmin or network admin. Edit the FTP settings for sending current readings and recorded data. You can also set up, and which is a very useful function, is the web storage account. You can go to the link and register for a new account. And once the account has been created, an email including the FTP settings will be set, which and it will be emailed to you, which will be used in FTP settings. And also it can be configured so that the lab personnel can access the read-only interface with the user logins. And then we can set up the monitoring and warning settings. We can edit the settings to enable a sending of current readings and warning reports and specify to whom it should be sent. And after that, we are definitely going to have to do a transmission test so that the data and errors, the data and temperature warnings are sent to right places and they are successfully, transmitting, and then there are no errors. And then finally, you can move the unit to the final location where to determine the final location, you have to put a lot of things in mind, like, the environment and if there's going to be any obstructions, and then how close is it to the source of internet or power supply. And then you can also use a feature, which is a radio signal check tool and channel interference tool to check your signal strengths so that there will be no communication problems. And here's a little diagram of what the settings window is going to look like. It's a simple, pretty easy to use. And here's a schematic for how the warning and data logging is going to work. As you can see, you have three different interfaces here. This is the web storage device. This is a FTP server, and this is an email server, which we can set up during the previous installation step here. And we have the other important portion of this device is wireless thermal recorder, also called the remote unit or data logger unit. The model number is RTR502. So this unit is designed to measure and record the temperature, and the range of this unit to the base station is about 150 meters. So after completing the base station setup, the remote unit setup can also be used, can also be set up using the RTR500W settings utility in the Windows same program. The registration step includes registering the serial number, group name, remote unit number, communication frequency channel, and then recording the mode, interval, warning monitoring, and upper and lower limits for measurement readings, and etc. So you need to set the enable download to on, and then once everything is set up, you can click register to send and apply the settings to the remote unit. So the probe must be kept immersed in a temperature vial filled with glycerol or appropriate fluid for that environment. And then sometimes the device itself, not the probe can be in the thermal controlled environment, but then because of the high temperature, it might cause damage to the unit itself. And then also, if there is any obstruction, a repeater may be used. One of the key factors for setting up this instrument in the lab is it has to be accurate. And in order to document the accuracy, we need to have a highly sensitive thermometer, which is calibrated by NIST or NIST traceable thermometer. And then we will put, we'll basically take the same vial or a beaker, and then we'll put the probes under test and the reference probe. And the most important part here is we need to let it stabilize so that there won't be any differences, and it should be in a isolated, stable environment. And then after the readings are stable and they don't fluctuate as much, we can take 3 readings with at least 5 minutes in between the readings, and we can use a calculator. First, we need to average the readings, and then we need to find the difference, and then the difference has to be applied as a correction factor in how much it's differing with the NIST thermometer. The correction factor can be applied using the adjustment tools in the RTR 500W software. And here are some real data that actually a unit has produced. And this was sent to me by colleagues from a different lab where they had set this instrument up. And unfortunately, I don't work there anymore, so I could not implement the full um, project. So here's the data that you can see date and time and all the temperatures, and you can see the fluctuations and the trends over time. Sometimes you can see like events like opening a door or something like that. What are the obstacles that one can face? So there are radio signal issues, physical obstructions, and metal cases of ovens and fridges may hamper the communication. Proper placement is necessary, and issue could be resolved using repeaters. There could be configuration issues, network configuration issues may cause, connectivity issues across the local area network. Calibrations might not work properly if not done properly under, strict conditions, isolated conditions. And battery issue may arise if placed directly inside the freezer or a fridge in the unit itself. So budget, I had anticipated a lot more than what it actually was. So this budget is calculated for 3 base stations for a lab that has 3 departments, and using at least 10 data loggers with probes. And with the cost and everything, it comes down to 4,344, which is not as much for the benefit that we're gonna get. So in conclusion, the wireless temperature monitoring project is a future for all industries that deal with having to follow strict temperature requirements and guidelines. The application further expands to food, hospital, pharmaceutical, and vaccine industries. And then the recent um, high demand in ultra low temperature preserved COVID-19 vaccine like Pfizer, Moderna has proved that the need of this monitoring technology is expanding even wider. So I'm glad I got to do this project because I learned a lot more, and I could have definitely implemented it if I was still working in the lab. And here are my sources. And if you're interested, you can go into any of these sites and learn more. Thank you very much.